So first and foremost, give you an introduction. Good evening, everyone. First and foremost, and heartful thank to you all to participate for joining us this evening. Your continued enthusiasm, curiosity, and engagement for what keep our Adda alive, transforming it from a simple gathering into a dynamic forum for reflection, discussion, and intellectual discovery. As a part of ongoing journey, we are delighted to present today's session, Cosmic Consciousness, by none other than Dr. Debiprosad Duari, a distinguished astrophysicist, a science communicator. Dr. Duari has dedicated over 2 decades to advancing astronomy education and public engagement. From directing research and academic at MP Birla Planetarium to holding a faculty position at the institution like Presidency College, Cambridge and Manchester, he is a fellow of Royal Astronomical Society and a member of International Astronomical Union. Dr. Duwari, the floor is yours. You can start your presentation and we'll be glad to hear. And once you complete the presentation, we'll open the floor for question. Dr. Duwari.
A very good evening to everybody present over here. It's a privilege for me to be invited at this particular discussion session of the ADDA. And it's really, I thank Dibyendu for inviting me. And I was interested because I was told that people from diverse background, academic background, interest, they will be joining this discussion. And that is my intention to reach out to every people, not only students, about our ideas about the concepts of the cosmos and which affects our not only our existence but our mindset as well, our psychology as well. So when I gave the name cosmic consciousness and it was given on the Facebook post, there were a lot of queries that am I going to talk about the scriptures, the Hindu scriptures? uh, because we know that in Vedas and Puranas, they have this mention about the cosmos and the relationship to our existence, our mind, our spirituality. But sadly, I don't know whether I should say sadly, this is not the case. To me, consciousness is to know about certain things which are present, but they are not apparent to our minds because they do not come into our everyday existence in a way that we live in our society or in our lives. So, to know about that and to talk about how they can influence our thinking, our mindset, even the question of who am I, even the question of why we are here, we are alive, and at least till now there is no living organisms that has been found everywhere. So let me start a presentation. It will be a snapshot survey because I have just less than an hour or so. It's a snapshot survey. I'll be happy to answer any questions. So let me just present the screen. Okay. Can you please tell me whether you can see the slide of the PowerPoint presentation?
Yes, sir, we can.
Yes, we can see it.
Okay.
Yes, we can see.
Okay. Thank you very much. So basically, the topic of our today's discussion is cosmic consciousness. Thousands of years back, when our ancestors used to look into the sky, they used to wonder, what is sky? Where is sky? What is the position of the earth with respect to the sky? And what are those lighted dots that we call stars today? Is there any connection between the star and the earth? With these set of questions and queries, the subject of astronomy was born. So astronomy can be considered as one of the oldest subjects that human minds have dwelt upon. At the same time, it is also considered to be one of the most vibrant subjects subject in our contemporary discussions, research, academics in science and technology. It is a subject which deals with not only the vast expanse of space, but also time, and it has the potential of unfurling the mysteries of the universal nature. Just to give you an idea about how important this subject has become in the recent era, from 1901 till 2000, only three and a half Nobel Prizes were given on the subjects of astronomy, astrophysics, cosmology, and general theory of relativity. Whereas from 2000 to 2024, six Nobel Prizes, 17 scientists were awarded the Nobel Prize on these subjects only. And that tell us what a gigantic amount of shift, a paradigm shift, has happened in terms of science and technological advancement, understanding, motivation, and creativity for these subjects. The night sky. Thousands of years back, when our ancestors used to look into the night sky, they used to wonder what are the meaning behind those lighted dots. But they couldn't find an answer. In their desperation, what they did, they chose different parts of the sky, identified closely spaced stars, joined those stars through straight lines, and created imaginary figures. In this way, the whole sky was divided into 88 regions, each region being governed by an imaginary figure, which we today call constellations or Taramandal. But we know that our understanding, our knowledge has gone much, much beyond that in the last 400 years. Why? Because it was the first usage of a telescope in 1609 by Galileo Galilei, which opened up the sky to the human mind. But that's a long story. In 420 years, technology, understanding of science, of nature, has gone through a tremendous quantum leap. And now, scientists all over the world, even the technocrats, the policymakers, they have realized that to make a progress in science, we have to look into the heavens. Every country, developing, underdeveloped, advanced, developed, they are desperately trying to build bigger and bigger, newer and newer telescopes. Just to give you an idea, it is very inhospitable terrain in the Atacama Desert of Chile and a place called La Paranal. They have built four 8-meter diameter telescopes. The place is so arid, within 250,000 square kilometers, not even a blade of grass grows. Here, when the sky is very clear, they are looking into the heavens, talking about stars. A small Hawaiian archipelago island called Mauna Kea. On top of Mauna Kea, 15 countries have built 12 telescopes. The smallest one cost is around $500 million. And we know that tomorrow another fantastic observatory is going to be inaugurated. That also in Chile, and that will be called a Vera Rubin Observatory. But India, let me tell about it. India has gone through a tremendous change in terms of research, academics, endeavors, technological breakthroughs in the field of astronomy and astrophysics as well, which most of us, because of different narratives that are floating around in the society, in the social media, we do not really understand or know about it. In 2018, Government of India declared seven mega science projects with a time frame of 10 years and with a fantastic budget of almost 20,000 crore rupees. And amazingly, out of seven mega science projects, six projects are directly involved on the subject of astronomy and astrophysics. So that tells you, though we hear a lot of stories, we read a lot of things that it is not happening, we are going back to Middle Ages, to early ages, and discussing all that, but don't forget, our nation is moving forward, guided by policymakers and of scientists to a direction which is making India at par with only 5 to 6 nations who are the topmost of research, observation, understanding about the cosmos. The sun, moon, and the earth. Most of you will think that it is only a pre-primary or even KG class, first KG or something statement. But if a small boy or a girl asks you, what is the speed at which Earth is going around the sun? Lot of people will not know the answer. 29.5 kilometers per second. In 1 second, 29.5 kilometers. Imagine a car. We will not believe it. But we forget. You, me, 795 crore people, millions of other forms of life existing on the surface of the earth. Every second of our existence, we are moving at a velocity of roughly 30 kilometers. Though we think that we are sitting tight or standing tight, whatever you are. The one thing which hit me when I started my studies in astronomy some 35, 40 years back was a fantastic realization that though we think we are so sure about us, about ourselves, about our existence, but we forget that, to me at least, life is a result of a series of chance happenings that happen to us. Our existence on earth in this whole cosmos is accidental. Though we think that we are all powerful nowadays, generation X, Y, Z, whatever it is, either intelligence or money or muscle power or connections, but we forget it all happened. Life occurred, it evolved. That I am alive at this moment. Everything is happening because of a series of chance happening. And this is, to me, the ultimate consciousness of us vis-a-vis the whole universe, the nature in the biggest scale. I will give you, trying to give you the proof of that. We all know Earth is tilted by an angle of 23.5 degrees around the axis of revolution around the sun and going around the sun. And it is because of the tilt season changes occur. Why they're important? If there were no change of seasons, there would have been no ocean currents. If there are no ocean currents, there would have been no air currents in the atmosphere. If there are no air currents in the atmosphere, clouds would not have borne somewhere and gathered somewhere else and gave us rain and fresh water. Without the change of seasons, life would not have been possible or not. So we exist because change of seasons, because of this accidental tilt of 23.5 degrees. Then take the tides. India has a large coastline, and at least 50, 60% of the population, they know what are tides. Every day, twice the high tide and twice the low tide. And most of the people know it is happening because of the moon's attraction. But it is not the full story. It is happening because of a mutual attraction of the sun, moon, and earth. Because tide is not a force, it is rather a force derivative. Whatever. In our class or 5 or 6, we have all learnt in our textbook, life first occurred on the oceans. So how did it come onto the land? Every day the high tide is to wash the shore multicellular organisms. Water is to go down, it is to get stranded and killed. But over millions of years they got the adaptation to stay alive on land. And from there different animals, plants, trees, mammals, reptiles, everything occurred. Monkeys happened, and we have arrived, at least if we believe in Darwin, from the monkeys. So that we are here is because tides were there. Then the position of Earth from the Sun, 15 crore kilometers away. Amazingly, scientists call this position the habitable zone of the Sun. Why? Because in this region, water can remain in liquid form. If you go to Venus, it is too hot. If you go to Mars, it is too cold. Everything is frozen. But we need liquid water because liquid water is the essence of life. See, that I am speaking to you. My brain is giving me the direction for the vocal sac to vibrate in a particular way so that sounds are coming out. But how the brain is giving this direction? Through neural electric impulses. But my body is not made up of copper wire that electricity is getting conducted. Every cell in my body is filled up with water and lot of other chemicals soluble in it. It's an electrolytic solution, every cell. And this electrolytic solution conducts the electrical impulses throughout our body to make it function. So it is not that I need water to drink, but it is also water is the essence of life on earth. And this water is present in the liquid form only around Earth's position from the sun. This is an accident again. For example, take total solar eclipse. These pictures are actual pictures taken during total solar eclipse. Sun was discovered as a new avatar. People found out milky white radiation is coming from the surface of the sun which cannot be seen on other times. When they asked themselves the question, what is causing this, they were amazed with the answer. They found out from the surface of the sun every second, on an average, 1.6 million tons of charged particles. 16 lakh tons of charged particles are coming out from the surface of the sun on an average. These charged particles, when they move through the magnetic field of the sun, they produce this milky white radiation. The average velocity of the charged particles are 450 kilometers per second. With that speed, they have enough energy. If they heat any atom or molecule, instantaneously they will get evaporated. Poof. That means when tomorrow the sun comes up, if I go out and stand on the sun, the charged particle coming from the surface of the sun, the moment they hit my body, within fraction of a second, my body, everything around me should disintegrate. But I am alive. How? I will come to that. Moon. Yes, people have landed onto the moon. 12 astronauts on 6 missions have landed, moved around, done a lot of experiments, and given us an idea, roughly an idea about what moon is. What is moon? According to 99% of the scientists, 452 crore years or 4.52 billion years back, a huge ball of rock came and slammed onto the earth. With such a force, huge amount of material was gouged up from the surface of the earth. It couldn't go away forever, but going to a very vast distance for millions of years, it condensed, coalesced, coagulated, and ultimately gave birth to the moon. This theory is called the collision ejection theory. And what happened to Earth? Because of the tremendous heat, it became molten and got tilted by 23.5 degrees, for which season changes occur. So the birth of the moon, which happened because of the presence of the earth, also gave rise to situations, conditions, which later on became very much useful for production of life on earth. Now let us start our earthly journey out of earthly bounds into space and time. Space, obviously, if I make a journey, I change the space. Time? Oh, I need some time. No, not that time. In 1905, Albert Einstein gave a lot of theories. I'm not discussing theories in this Sunday evening, but out of that came the ideas, which was earlier also understood. Light has a velocity, 3 lakh kilometers per
Time
second
on you.
in vacuum. The distance from Sun to Earth is 50 crore kilometers, 3 lakh kilometers per second velocity. If you do a simple division, class 7 or 8 geography book, then nowadays
Now
it
it's
is
night.
mandatory to write.
Not say evening anymore.
Excuse me, somebody is, I think microphone is on. Baby voice can be heard. If you kindly mute your mic, it will be better. Okay. The distance from Sun to Earth is 15 crore kilometers. 3 lakh kilometers per second is the velocity of sound. If you do a small division, Sun to Earth, light takes 8.3 minutes to travel. And it is said Sun is 8.3 light minutes away. What does it physically mean? Tomorrow, when I'm going to look at the sun for a fraction of a second, I have to tell myself the sun that I am seeing now is the image of the sun as it was 8.3 minutes back. The closest star to our solar system, Proxima Centauri, 4.2 light years away. In the evening, with a binocular, if you look at the star tonight or tomorrow, you have to tell yourself the star that I'm seeing is the image of the star as it was 4.2 years back. So you understand the significance. Next time, the kids in your house, if they tell you, please take me to the science city, Spend 50 rupees on a time machine ride. Don't. In any clear night, out into the open, tilt your head. The deeper you are seeing your own past. We don't understand. Looking at the sky, especially in the night, is a time travel for everybody. Time travel to the past. That is why there is this sense of romanticism, sense of query, sense of discovery when we look up into the sky. Our first topic in the journey will be the solar system. These are all the main avatars of the solar system in their true colors, but this is actually a painting. Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Pluto has been shifted from the planet position. Sun, we all know. Sun is a ball of gas. Acha, my friends tell me, if you take a football, pump in a lot of colored gas, cut open the football, will the gas inside remain as a ball? It will diffuse out. Then how come sun being a ball of gas is not diffusing out into the sky? What does the scientist say? According to the scientist, 460 crore, 4.6 billion years ago, a huge cloud of gas and dust was floating in space. This cloud was made up of 91% hydrogen, 8% helium, the helium gas which is used for these balloons, which fly, and 1% rest all other elements. The average temperature of this gas cloud was minus 240 degrees centigrade. At this very cold temperature, in a gas cloud like this, out of the four fundamental forces of nature, only one type of force comes into play, and that is the force of self gravity. The force of self gravity will attract the periphery towards the center. As the gas goes toward the central density rises, pressure builds up, temperature rises. And starting from minus 240 degrees centigrade, the temperature rose to a fascinating level of 1.5 crore degrees centigrade. At 1.5 crore degrees centigrade, what happens? As if four hydrogen nuclei, the centers of atoms are called nucleus, four hydrogen nuclei, they as if come together, fuse together, and produce a helium nucleus. This thermonuclear fission reaction, our scientists have been able to perform it, but most of the time, till 7 years back, they could not control it. So it was used to explode a hydrogen bomb, hydrogen to helium fusion. But inside the sun, in a very regulated manner, when four hydrogen goes to helium, huge amount of energy is produced. This energy, as it tries to come out, it produces a back pressure towards the surface called the radiation pressure. This radiation pressure, it exactly balances and matches the inward force of gravity. Sun, being a ball of gas, remains hanging there for millions of years. Just imagine, we think we are so powerful, but each individual existence is happening because 15 crore kilometers away in a ball of gas, two opposite forces are continuously cancelling each other every second of our existence. This is the consciousness I'm talking about. Sun outwardly has three regions. The surface of the sun that you get to see early morning or late evening looks like so smooth and orange in color, but it is not so smooth, right? Here is an actual picture. It has this cell-like structure. These are cells of plasma, hot gas, coming from the from the inside. As it is coming up, it is containing the heat, so it is lighted. The moment it comes to the surface, it deposits the heat as sunlight, rays of sunlight, becomes cold, like a fountain goes down and continuously bridges the heat from inside. This is called the photosphere. When we see sun during a total solar eclipse, we see spikes of exquisitely pink colored gas, reddish colored gas coming out from the surface. That is called the chromosphere, chroma means color. And one of the best picture that nature can provide us, again during a total solar eclipse, is called the corona. This is an actual picture I'm taken on 2023. You are seeing the moon, which has totally covered the sun, and you see the milky white radiation coming out from the surface. Right? The word corona in Latin means crown. So it is the crown of the sun that we are going to see. Sun is not a very smooth, very mundane, quiet object. Sometimes these are all actual photographs, by the way. You get to see black splotches, kale dhabbas on the surface of the sun. Sometimes one, sometimes 10, 20 in a group. They're sunspots. What are they? The surface temperature of sun is 2600 degrees centigrade. At that temperature, gas cannot remain as gas, it becomes plasma. Plasma, wherever there is a magnetic field, plasma tries to get deflected from it. On the surface of the sun, small pockets of magnetism form. A column of plasma trying to bring the heat from inside. If it realizes that there is a magnetic field over it, it will not come out straight. It will take the heat away from different directions. No heat comes out from this region. It will typically remain look dark. This picture was taken in 2012. I was told this single picture, arrangement of the picture, costed $1.2 billion by NASA using a satellite observatory called Solar Dynamical Observatory. Sun is not a smooth object. Tremendous amount of explosions are happening every second. Thousands of tons of gas are getting thrown out from the surface, reaching a height of 25 to 30,000 kilometers, making beautiful arch and loops falling back onto the surface. Sometimes they get thrown out with such a force they get detached from the surface of the sun and flow past the whole solar system like a solar wind. Actual picture taken in 2016. You see from the surface the gas coming up and falling. Do you know what is the size of this cavity of this loop? Three Earth, three Earth will go side by side inside that. And this is our everyday sun, right? And I told you this charged particle, if they hit me, you, building anything, instantaneously generate. Poof, that's sort of evaporation. Why are we alive? We are alive because of again an accident. By accident, Earth behaves like a bar magnet outside the Earth, like an invisible shield, like a peels of an orange. There is an invisible magnetic shield. These charged particles, they come and slam onto the magnetic shield, cannot enter, flow past the Earth, and we think we are the king and queen of ourselves. But in the northern or southern magnetic polar region, there is some sort of a gap. These charged particles, they do enter the atmosphere. Before hitting the ground, hitting you and me, destroying everything, they interact with the air molecules and make them glow. And what we get to see? Aurora. Aurora borealis in the northern hemisphere, Aurora australis in the southern hemisphere. One of my friends, she's an Arctic scientist, took a fantastic picture last year from the northernmost part of Finland, almost in the Arctic Circle. And it tells us the sheets of ice, snow, it is reflecting the sky, and you can see the aurora borealis that is happening on the sky. Our solar system, how did it happen? According to the scientists, 460 crore years back, when from the disk of gas and dust, sun was getting born at the center in the outer periphery, but the temperature was a little less. Gas and dust condensed, collided, coalesced, gave birth to very hot spherical objects. For millions of years, these hot objects dissipated away the heat, and at least the first four planets, Mercury, Venus, Earth, Mars, became rocky, terrestrial, solid, whereas Jupiter, Saturn, Uranus, and Neptune are mostly made up of gas. This is a collage of all actual colored planets. Mercury, Venus, you cannot see the surface, covered by a thick layer of cloud made up of concentrated sulfuric acid. And the atmosphere is 96% carbon dioxide. Because of this cover of clouds, the greenhouse effect is so critical. It being the second planet, is still the hottest planet in the solar system. Next is our Mother Earth. Let us not discuss about Mother Earth tonight. Next is the red planet Mars. Why red? It is rusting on the surface. Ferrous and ferric oxide covers the whole surface. But this 2002 photograph taken by Hubble Space Telescope, scientists are interested because in the polar region they have seen a white sediment. According to them, this white sediment may be a mixture of water ice, dry ice, that is carbon dioxide ice, and maybe methane ice. So their understanding is even if a part of it is water ice, maybe liquid water is to flow, millions of years back on the surface of Mars. And on Earth, even a drop of water means millions of lives, multicellular, single cell lives. So, was there life on Mars? Is there still life on Mars? This is a big question. Next is Jupiter, 319 times heavier than Earth, takes 11.86 years to go around the sun once, but takes only 10 hours to go around itself. With a tremendous spinning speed, it has dragged the clouds of the atmosphere and created this elastic belt-like structure. Next is the most beautiful planet, Saturn, with a fantastic ring system. Takes 29.4 years to go around the sun once. Has till now 240 satellites, moons. Uranus with a ring. Neptune blue in color covered by methane bearing clouds. Mars has been important because of these geomorphological structures. As if millions of years back, liquid water has cut through the mountainous region and created these ravines. Every year, on an average, few hundred kilograms of rock come scattered from Mars and land onto Earth. My friend, if on the surface or below the surface, if there is water ice, drops of water, permafrost, there can be bacteria, parasites, viruses. Sitting on a rock, if it lands onto Earth, as it happens regularly, within 6 months to 3 years, the whole life form may found to be in a very critical position. So it is not just for the scientific endeavor, just to understand the sky. Scientists, technocrats, countries are providing missions to Mars, spending billions of dollars, including India. In terms of Mars, I have to tell one thing. I'm a very proud Indian, not just the feeling of pride, but one after another, analytically. If you judge whatever is happening in the last 20 years or even 30 to 20 years, last 10 years, India at present is one of the leading countries in the world in science and technology, and especially in space science and astronomy. 15th of August 2012, the then Prime Minister declared the Lok Sabha India is ready for a mission to Mars. Almost every country looked at India with doubt. India's technological achievement is not that much that they can send a mission to Mars. But to cut the long story short, we know Mangalyaan, Mars orbiter mission, took off from the Satish Dhawan Space Center, Sriharikota, in 2013, and 24th September 2014, 8:02 a.m., India became the first country in the world in its very first trial, successfully entered Mangalyaan on a stable orbit around Mangal or Mars. No country has been able to do this in his very first attempt. That is India. That is the new emerging India. And we know, we read in the newspapers, in YouTube, in television channels, huge amount of projects already lined up. Some already done, some are being looked at. Right? Chandrayaan 3, it's a recent happening. 14 July 2023, it went on to space, sitting atop a GSLV Mark III rocket. And 23rd August, India again achieved the milestone of being the first country to successfully land near the south pole of the moon. No country, because of lot of technical difficulties, because of the terrain, because of the magnetic field, because of since it was not known what is the situation, they tried but failed. But India did it. And this picture was taken of the Vikram lander by the Pragyan rover on 30th of August. One of the most highest resolution camera ever sent on the moon by ISRO. So it is not just the pride, it is the realization that how India is progressing, like in all other sectors that are more prominent than this science and technology. Astrosat, looking at the sky at different wavelength bands, X-ray, optical, ultraviolet. Aditya L1, to understand what is the behavior of sun's radiation, what is its effect on our Earth's atmosphere. A new term, space weather, has been coined. And we all know Gaganyaan is a happening thing. In 2026, probably taking two astronauts, Gagan Jatris, this capsule will be going on space for 3 to 4 days with a humanoid called Vyomitra. Nisar, another one of this is the costliest spacecraft ever to be sent. $1.5 billion just the spacecraft. What does NISAR stands for? NASA ISRO Synthetic Aperture Radar. It's a collaboration between NASA and ISRO. So, yeah, today's young generation, today's students, they should understand the horizon of India's adventure, India's progress in science, technology, space science has reached such a level. It is not only at par with the most advanced nation, but sometimes overpassing it in their celebration of what is called the national pride of science and technology. 1801, Italian astronomer Giuseppe Piazzi discovered a piece of rock 900 kilometers in diameter between the orbit of Mars and Jupiter, named it Ceres. People thought a new planet has been discovered, but soon three more objects, 500 kilometers in diameter, were observed in the same region between the orbit of Mars and Jupiter going around the Sun: Pallas, Vesta, and Juno. People realized a new class of object is getting discovered. And from that day onwards till today, thousands and thousands and thousands pieces of rock, 10, 20, 50, 100, 1 kilometer has been discovered between the orbit of Mars and Jupiter going around the Sun. This image is a true representation of NASA. Here, each green dot is a discovered and named asteroid. And the red ones, they are called Apollo asteroids. Their speciality, their orbit intersects the orbit of Earth. That means they are going around the sun. Earth is going around the sun. Any moment, one of these Apollo asteroids can come and hit the Earth. The collision may be so large, even a part of the Earth can be totally destroyed, evaporated. If you ask me when can this happen, believe me, my friends, any point of time. Today, 10 years later, 10 lakh years later, nobody knows. So that we are alive is accident. If I take you out of the solar system, twinkle, twinkle, little stars. These are all actual photographs. You will say, this is now, you are trying to hoodwink us. When you look into the sky, two dots, stars, planets, nothing in between. Why? Do you know why we don't get to see these pictures? The problem is with the human eye. Human eye has something called perception of vision. Within 1/10 of a second, whatever amount of light enters through our pupil falls on the retina. The optic nerve immediately takes them to the back of our head, called the optic lobe, and tries to sketch the image that we are seeing.
Oh yeah.
Our eyes cannot integrate, add light like a CCD camera. If our eyes were like a CCD camera, looking at a particular direction in the sky for 10, 20, 30, 40, 100 hours, you should have seen every dot in the sky. There is a star and huge gas clouds. Are all the stars like sun? Here is a big question. You should understand how interesting is the subject. Looking at a photograph of a person, can you tell what is his body temperature, what is his mass, what is his age, what is going on inside his body, what is life? It's not possible. But don't forget, looking at an image of a star, you have to answer all these questions. So, one has to be resourceful, tremendously resourceful intellect wise to understand. And that's why astrophysics is a challenging but a very demanding subject. And when the light comes to a prism, breaks down into its constituent wavelengths, we get what is known as a spectra. And from these spectra, what is the temperature, what is the pressure, what is the density, what are the type of elements, what are the molecules, everything becomes apparent just from the signal of light, which is so fascinating. By the way, do you know who was the person who first in 1920 gave an equation which helped to understand star just looking at the spectra? I don't know whether today's generation, young, very young boys and girls know the name. Meghna Shah. See, an Indian. right? His Shaha ionization equation had made it possible for the scientists, and he is called everywhere in the world, believe me, father of stellar astrophysics. But I don't know what is happening in India. Stars can come very different initial masses, temperature, chemical composition. In terms of mass, 0.08 to 150 times the mass of Sun. So what is the mass of Sun? 2 followed by 30 zeros. 2 30 zeros kilogram. In terms of surface temperature, the central temperature is 1.5 crore, hydrogen to helium. But the surface temperature can range between 50,000 to 1800 degrees centigrade. It was a legendary woman 120 years back at the Harvard Smithsonian Astrophysical Observatory, Mary Cannon. In 7 years of research, she looked at the data of 240,000 images of stars and their spectra and created an index. The hottest surface temperature, let us call it O star, next hot B star, A star, F star, G star, K star, and M star. In 100 years, science has totally changed. Nobody can touch our index. Sun with a surface temperature of 5,800, 600 degrees centigrade is a G type of star. That brings me to the life and death of stars. Stars are born from interstellar clouds of gas and dust. What does it mean? When you look between the two stars in the sky, it is totally black. Nothing. No. There is huge amount of gas cloud which our eyes cannot understand, see. These clouds are called interstellar clouds. I want to show you some of the pictures. See this actual picture. But don't mix it with the clouds that you see in the sky on Earth. Because from one of these clouds, 1000 solar system can be born. For you, I have collated some of the very recent, very colorful pictures of this interstellar cloud. See for yourself. Isn't it beautiful? The sky, which looks dark to us, maybe with some stars, spattering stars in the cities. And if you go to Himalayas or a very dark region, you see a lot of stars. But in addition to the stars, these are the objects which are giving birth to stars. So if you are born, you have to die because my lecture session is only 1 hour. Stars die in different ways depending upon their masses. Stars whose initial mass is 1 to 8 times the mass of Sun. For example, Sun. It is alive because it is burning hydrogen to helium, energy is produced, pressure is released outside, this pressure balances the force of gravity inward, and star is born, producing its own energy. How much material is present at the core of the Sun for this burning process, fusion process? Scientists have realized another 500 crore years, 5 billion years, Sun will be burning hydrogen to helium at the core. When all hydrogen gets into helium, the thermonuclear fusion reaction stops, energy production stops, outward radiation pressure stops, but gravity is always there. So Sun will shrink. As it is shrinking in the outer layers, there are a lot of hydrogen still remaining. Because of the contraction, the temperature rises at the outer layer to 1.5 crore degree, which was earlier at the center. At that temperature, in the outside layer region, hydrogen fuses to produce helium, energy is produced, gas when it is heated expands. So, after 500 crore years later, Sun will start shrinking, suddenly stop, and then it will become bigger and bigger and bigger. How big it will be? In a small calculation, it can be shown. After 500 crore years later, Sun will become bigger and bigger and bigger and ultimately touch the orbit of Earth. Yes, my friend. It will be called a red giant star. When the outside is becoming bigger, the inner core of helium, because there is no energy production but gravity is there, so it contracts. As it contracts, the temperature rises from 1.5 crore to 10 crore degrees centigrade. At that temperature, three helium nuclei fuses together and produce a carbon nucleus. This helium to carbon production again generates heat. The inner core of helium stops shrinking. But soon, all the helium will get converted to carbon. Since the initial mass of the star is 1 to 8 times the mass of the sun, it is not enough to produce more gravitational pressure to raise the temperature to 1000 crore, 10,000 crore, trillions of degrees centigrade. So the inner core remains very hot, ball of carbon on the sky like a dot. It will become bright. It will be called white dwarf star. White dwarf. By that time, the outside has become so big, it starts getting detached from the surface of the sun and create a cloud-like structure called planetary nebula. The word nebula means cloud. You think that most of you think that I'm talking about science fiction. This is an actual story in the background of a planetary nebula. Red giant, white dwarf, outside planetary nebula. Right? I want to show you actual photograph taken last year. See for yourself. So in addition to those lighted dots we call stars and planets, these are the objects present in the sky telling us the evolution of cosmic objects. And it was later on we found out, mostly my group, when I was in Manchester, we did a lot of mathematical calculation, supercomputer calculation, and showed as the star is becoming bigger, the outside, it is producing shocks. And these shocks can produce molecules. Nobody believed it. But in 1996, Holland sent a spacecraft, and out of 72 molecules predicted out of our model, 68 were discovered. Believe me. And we came to know the death of a star is also the process of synthesis of chemicals. And a new subject which is already there became more vibrant throughout the world, astrochemistry, right? Synthesis of molecules in space. And it's a little serious slide. These are the molecules that were predicted and discovered. Can you notice one thing? Most of them are organic molecules. So, Earth is not the only place for life to happen. Any star at its end phase can produce the prebiotic material, the seeds of life, not life, prebiotic material for life. And that led us to the next type of death. Stars whose initial mass is 8 to 25 times the mass of Sun. Here, hydrogen to helium at the beginning at the core, helium to carbon, volume is more, mass is more, pressure is more, temperature rises. Carbon to oxygen, to neon, to magnesium, right, to silicon, and ultimately it ends at iron. You cannot pressurize iron for the nuclei to fuse together. So the inside of the star takes like the shape of a so peels of an onion. Hydrogen, helium, carbon, layer after layer, and ultimately iron. When this stage is reached, the thermonuclear fusion reaction stops. Because of gravity, all these layers with a tremendous speed tries to get fall into the iron core. The poor iron fellow has nowhere to go. It tries to compress, but beyond a limit, it becomes incompressible. So all these layers just slam onto the iron core, get a kick, a recoil, and ultimately explodes. At the point of explosion, the temperature reaches few trillion degrees centigrade. And starting from iron 26 to all the naturally occurring element in the periodic table, every material, every element gets produced in a fraction of a second. Since they are produced in a fraction of a second, they cannot be produced in huge quantities. And on Earth, most of them are called rare earth elements. And believe me, my friend, the blood in my body, your body is red. Why? Because of red blood corpuscles. What in red blood corpuscles? The iron. We all know. If you don't get much iron, we have anemia. You have to take some medicines or tonic or something. Close your mind's eye and ask yourself, where from a single atom of iron has come in my body? Through my food, through nutrition. How in food? If I'm a non-vegetarian, I've eaten the goat, which has eaten the plant. If I'm a vegetarian, I've eaten the plant. Where in the plant? Oh, from the ground. How in the ground? Because according to the scientists, at the very birth of the universe, 1,377 crore year ago, in a situation called the Big Bang, only two elements were mostly produced, hydrogen and helium. All the rest other elements that we see around has been produced inside a star through this fusion process. So my friend, my body, the iron, the calcium, potassium, zinc, whatever my body, everything around us is made up of star dust. So it is not fancy free, it is not romantic, it is not imaginative to say you, me, every living organism on earth, we are all star children. Because of this explosion of star, which is called supernova explosion. So our body is made up of stardust. I don't have much time, but just to tell you, starting from gas, a star is born, and at the death, again the gas is produced. But in between, there's a tremendous amount of chemistry that is going changing dynamically. And as if a khichdi, you know, a, a pot recipe is being made inside the interstellar medium. And this has given birth a very recent subject, 40, 45 years back, of what is life? How life happened on Earth? Is there life anywhere else? Are we alone? So, to understand what is life, scientists from 1957 have desperately tried to create life, not produce, not reproduce, produce life, but they have failed. So now, most of the scientists have started believing the material for life, raw material, the organic material for life, was not present on Earth. It came from outer space. Through these collisions of comets, meteorites, when all stages of the solar system, when Earth was bombarded, these materials came, and using the then atmosphere, environment, chemistry of Earth, life suddenly sprang up. Nobody knows how it happened, how the shift from non-living to living happened till today. So, a new subject is coming up: astrobiology, astrophysics, astrochemistry, astrobiology, astrocomputing, astrostatistics. It is the most vibrant subject. Today there is not much time, but if someday you are interested, we can talk about black holes, which are also end product of huge massive stars. The gravitational attraction toward the center is such that the end part, it doesn't produce a supernova explosion, but get contracted to almost like a point like existence with infinite energy. It attracts everything around it, and it will not allow light to come out of his clasp. And they are called black holes, which can be understood by the fantastic concept of Einstein in 1915-16 when he gave the general theory of relativity. He said gravity is not an attractive force. It is not a force. Any body, because of its mass, creates a curvature in this four-dimensional space and time. More mass, more curvature. And any object sensing that curvature will start coming towards the bigger object and touch it. That is gravity. Gravity is the geometry of the space-time created by the mass. And in that concept, a black hole can be understood as if a tear, a hole in the as if a hole in the space-time. Material falling in will never come out. And only 5 years back, this event horizon, material falling onto a black hole. You cannot see a black hole. This disk of gas material called an accretion disk has been found in a very, very far away, very large galaxy center. And only 5, 6 years back, they found the black hole present at the center of our galaxy called Milky Way galaxy. The Nobel Prize was given in 2020 for that. Hayes and Genzel, right? So now we talk about our galaxy because I have only 4 or 5 minutes. We are a part of a spiraling collection of stars and gas. How many stars? Roughly around 20,000 crore stars. And we are not at the center. We are not so special. We are situated 28,000 light years from the center of our galaxy. Our galaxy is huge. Light from one end to the other end take 1 lakh years, 100,000 years to travel, 1,000 light years. And we are 28,000 light years away. And our sun is not fixed, sitting at rest. Sun, with all of us, with all the solar system, is going round the center of our galaxy at a tremendous speed of 220 kilometers per second. There are different types of galaxies in the universe: spiral, lenticular, elliptical, irregular, and this picture is the latest. Here, each dot is not a star. Each dot is a collection of 10,000 crore to 20,000 crore stars called a galaxy. Think of this. Looking at this, a lot of students say, Sir, I feel so inferior. Each is a galaxy. Our star is the smallest speck of dust, smaller than that in a galaxy, our sun, and we are a part of the solar system. How small we can be? The answer is don't forget the human spirit, the human intellect. Within the 25 to 30 centimeters of our brain, we can visualize, we can see, we can analyze, we can theorize. That is the power of human mind, human brain. And everybody should use that for the fullest expectation that what is the potential of a human mind and a human brain. So the most subscribed theory is that the beginning of space and time, the origin of matter and energy, started from almost a small point-like area. Point has no physical meaning. Point has no dimension, no length, breadth, height, but a point-like area. And in 1,377 crore years later, it has become our universe. This concept is called the Big Bang hypothesis. But still the question remains. Is it true that 13.77 billion years ago, just from a small region, our universe expanded to today's size? And later on, people have realized if you ask the question, where was that point? When, before that point, what was time? Earlier, scientists said, don't ask this question. These are irrelevant questions. Space and time started from that point. But now we know they're talking about something called a quantum fluctuation of energy, a little small, little great in every point in space. And earlier, out of this quantum fluctuation of energy field, not one, but many universes were born. Our universe is one of them. But we cannot connect to the other universe because they are so far away, the light travel is not possible even. And this gave rise to a new concept called multiverse. Our universe is only one of the billions of millions of other universes in a much bigger scale than we earlier thought about. So you see, the cosmic horizon is expanding. But one thing, as we are going outward in our mind, in our observation, in our discoveries, we are also realizing there is another cosmos. That cosmos is within us. How much do we know about our inner self? As if that is a cosmos also. So, whatever we see around, there is a reflection of those feelings, emotions, understanding, realization within ourselves. And that is the true consciousness. So, technology is playing a tremendously important role, all subjects of science and technology. But mathematics is very important, right? Computational challenges. For example, if you take the Vista in astronomy, all these words nowadays you get to hear everywhere: AI, ML, DS, artificial intelligence, machine learning, deep learning, large data, data analytics, simulation, innovative software. Almost every of these started with astronomical research because of the huge data set. In addition to that, photonics and quantum optics, nanotech, electronics, communication technology, everything is going through a sea change because of the requirement of understanding the cosmos using the latest cutting edge technology needs all this input. CCD technology, segmented mirrors, active adaptive optics, interferometry, quantum optics, everything, every subject under the sun or rather under the banner of science is getting involved into astronomy. Right? So it is not just the age-old ideas that pure science, physics, chemistry, mathematics, biology students are needed. Astronomy and astrophysics needs electrical, electronics, mechanical, structural, space science, rocketry, telecom, IT, computer software and hardware, instrumentation, and data scientists expert. So this is a call to the younger generation of the country. Don't think that which happened 10, 15 years back, there was a tremendous rush to IT sector. It is needed, but there is a tremendous potential sitting in front of you, which is supported by your government, which is supported by the superior intellect of the Indian mindset. thousands of years of understanding, intuition, studies has created today's resurgence as if a revolution of understanding everything around us, including the sky. So our horizon is expanding, literally because universe is expanding, as well as through these studies, through our observation, through the big telescopes. And then if we really think of the sky, I can only think of Rabindranath Tagore, his music, his words. How many of you know that Rabindranath Tagore in 1937 has written a book called Vishwa Parichaya? Everything I'm saying today, in a nutshell, though not very scientifically verified, in a nutshell, has been described by Rabindranath Tagore. So, my heart sings at the wonder of my place, in this world of light and life, at the feel in my pulse of the rhythm of creation, cadenced, illuminated, cadenced by the swing of endless time. Those for you who are Bengalis, you know this Ravindra Sangit, আকাশ ভরা সূর্য তারা বিশ্ব ভরা প্রাণ তাহারই মাঝখানে আমি পেয়েছি অবস্থান থ্যাংক ইউ ভেরি মাচ
Thank you, sir. I want to ask the question. If a multiple universe exists, do they affect us in any way, or they are completely separate worlds?
If there is a multiverse, in no way their happenings, their situation will be affecting us. Because I told you, we cannot communicate with the multiverse. It is in pen and paper, theoretical, mathematical structures, not reality as we get to see. That is the whole situation.
Gautam, you want to speak? You want to say some question? You are mute.
Yes, thank you, Dr. Duari. I would like to first say that if the virtues of intellect, wit, and communication skills are all merged into one person, a star is born. And we are fortunate today to be led by a star of that kind to go through the journey of stars in the perspective of life. Thank you so much, Doctor, for this fascinating journey to take us through. We are all very ignorant in the domain of astroscience, so to say, but there are certain statements that you made which make us feel that we should be curious, we should be pursuing our chase for acquiring knowledge in whatever way it comes, leaving the Google on one side, but understanding the science and technology and the realms of science through such illuminating talks. And the parting comment that you made, that it is not just realization of the universe in the outer space, but also looking inward and through the introspection. So gratitude and reverence to you, Doctor. Thank you so much.
Yeah, Subhendra, Rohit, Kaushik, you want to ask some question?
No question from my side. But thanks, Dr. Duari, for excellent, uh, for this presentation and touching so many aspects of the universe and what we are very curious but are not able to sometimes follow or understand. So thanks for making it so simple and legible for us. Thank you.
So carry on.
Thank you. Thanks a lot, sir. This same thing. I will also say the same thing, that perhaps I could not follow everything, but it was a tremendous journey, a really fascinating journey. Now, just one thing to ask. Actually, it fascinates me for long, and I'm just putting it something like this. Listening to you, it looks that we, the living beings on our planet, extremely close to the cold pole of the temperature spectrum. Is this an arbitrary location on this cosmic scale of temperatures, beginning with minus 27 to 76 degrees or something like that, and going up to trillions of temperatures? Or does it have something very serious to do with the origin of life anywhere?
Definitely. See, the origin of life needed one condition. All the materials should be present which creates life, and the circumstances, the environment, the temperature, water, everything should be present together to create this magic thing called life. So at that this temperature, yes, even at high temperature, people theoretically have found out theoretically there can be life. Very cold temperature, not very cold, but more or less very cold temperature, there can be life. But here it happened, and it has taken the form that the way we see each other, the way we see the living organism, the way we see the plants and trees. It can be a different shape anywhere else in the universe where life has happened, but we can recognize them like us. They cannot have two eyes, two hands, two legs. They can be, as science fiction says, little green men. Nobody knows. They are all imaginary, all movie stuffs. But life can be of a different form. Our life is carbon based. There can be silicon based life, as some scientists have suggested. So this is the wide dimension of possibilities of life. But we, as humans, as animals, as existence of a collection of atoms, molecules in a way, we still today we cannot really fathom that type of existence is difficult, right?
Rajdeep, you have raised your hand. Please ask the question.
Okay, good evening, everyone. And sir, being a past students of us, sir, it's been always an amazing experience. Attended this type of lectures from Duari sir, and it's obviously a privilege to present in this group also. So, sir, it is always amazing to understand the cosmic consciousness and the world above us. But it is really amazing. I feel amazed to find out theory about, or not a theory, that about all the constants in our universe, all those specific constants, the gravity, speed of light. So it is. How could you please describe that the likelihood of creation of life in this universe is very thin. We have studied that also. So, is it a grand design? I would like to ask. Means how you explain this, or how you see this? Means every constant is so minute and perfect, and it's clearly making a perfect condition for life on Earth. So, how you explain this?
See,
All these
it
constants.
is not it is not Earth only. Everything that is happening around us. See, a tsunami, a typhoon, rainfalls, the sky being blue and clouds gathering and creating a particular situation in a particular place. Everyday existence of nature, its manifestation, is a part of the grand design. This grand design is not by a particular agency or a person. This grand design is because of what we call as the basic rules of nature, laws of nature, the way we have seen it. That doesn't mean that those are the only rules. That doesn't mean we are talking correctly. 200 years back, what we knew about science, a lot of things have totally changed. We now have an opposite view of what we are having 300, 400, 500 years back. So science is a dynamic, evolving subject. And that is the interesting part. Every second, every student, every researcher has a potential of defining science, of defining these physical laws in a new format. But we have to start somewhere, take some concrete steps, create a foundation for our understanding, and then move forward. If we start, what will I say, doubting the truth, it apparently is the truth by experiment. But is it the truth? Is it not the truth? That is science for to answer. But we have to take a methodology of moving forward in a structured manner. So that's where you can call it a grand design. How did life happen? But we are trying, but we have not yet fully understood that. And this is true for anything, even the constants. We have tested a million times and found out the value of the constant is whatever we believe on. But under the circumstances that we see around us, time can be constant can be time dependent. Who knows, right? So the dipole moment and other things, the velocity of light, gravitational constant, you do not know whether they are evolving also. There are suggestions, mathematical prediction, but whatever is observed till today tells us those are constant. That's it.
Uh,
Thank you,
Onik
sir.
Banerjee.
Thank you.
Yes, thank you. Thank you for giving me great opportunity to talk. Also. Sir, you are mentioning that the science kind of not like complicated and stored in a pure science kind of physics, chemistry, and other subjects can join the astrophysics parts.
Yes, yes,
Also, you say that AI, machine learning, deep learning, and data scientist kind of roles and kind
yes,
of course that recent time we are studying
right.
because I'm a data science graduate. That's why
Okay.
I'm very excited to know that how to join this the astronomical research kind of purpose.
If you happen to see the internet or the newspapers, every year there is this admission call for PhD research programs by some of the top 20-25 institutes in India. And you will see computer science is one of the main subjects they want people from computer science. Because think of the huge amount of terabyte or petabyte amount of data coming. Without a data analytics person, without the large data sort of manipulation, without computation, without simulation, we cannot do, we are lost. So computational challenges is playing a big role in today's astrophysics, astronomy.
And sir, there is a, you also mentioned the point. There's a machine learning kind of deep learning kind of things that are basically used nowadays for manipulating data kind of things. How
Yes.
to help this kind of technology to astrophysics?
See, see, the point is that the precursor, the ancestors of machine learning, deep learning, everything started 40, 45 years back with the sense of what is known as fuzzy logic. And you'll be amazed to know huge amount of data and not manipulation, analysis happened using fuzzy logic. And you train the computer and the nodes pick up through parallel computing, parallel processing. Things have been done 40 years back, 50 years back. So the new avatars of those fuzzy logic understanding in a much finer way. The AI, ML, and DL are getting used in a big way for data analysis of astronomical objects.
Shomujit Tiwari, if you kindly
Thank you,
ask
sir.
the question.
Yes, sir. Sir, my question is easiest question, but I'm not satisfied with my question. Till uh, could you please briefly explain about the point-like area on the origin of the universe? অ্যাকচুয়ালি বাংলায় বলছি যে যতগুলো সেলেস্টিয়ালস এর অবজেক্ট আছে আমরা তার যদি ভলিউমকে সাম করি তাহলে যে ভলিউমটা দাঁড়াবে সেই ভলিউমটাই কি সেই পয়েন্টের ভলিউম হবে, যদিও আমরা জানি সেই ভলিউমটা জিরো মানে ডেনসিটি হাই, তো আমরা ভলিউম জিরো করে সেটা ইনফাইনাইট করি, ইনফাইনাইট টেন্স পয়েন্ট। তো এতগুলো অবজেক্ট, এত হাই মাস হাই ভলিউমের অবজেক্ট গুলো মানে একটা জাস্ট পয়েন্ট থেকে ক্রিয়েট হয়েছে দিনের পর দিন, তো সেই ভলিউম গুলো কি সামেশনটাই সেই পয়েন্ট?
দেখুন, প্রথমেই I'm talking in Bengali because the question was asked in Bengali.
Sir, please, sir, if you kindly speak in English because there are a lot of crowd.
Okay, okay, whatever.
Thank you.
You are very worried about this concept of a point. First of all, the point, the term point and the term infinity has no physically palpable meaning. A point, if you draw a dot on the paper and say it's a point, there are millions of dots in that dots, micro dots. So what is a point? A point has no volume, no length, width, height. So talking about something becomes a little uneasy for us. For example, if I tell you another of these fundamental things, we talk about electrons, right? Have you ever come across this word? What is the radius of an electron? Right. So point-like object. What do you mean? Right. We know if two electrons come together, they will repel. But if they come together, the gravitational force will also take up role. So there are a lot of, as I can say, discrepancies in our understanding. But each day, slowly, these discrepancies are going away, and slowly, the truth, as we define it as truth, is becoming apparent. Right. So your question also has some deep philosophical meaning as well. But philosophy is a part of science. You have to understand that. When science ends, philosophy takes over. And you will say, oh, you are saying something very cliched. No. In your childhood textbooks, whoever was called gave scientific theories, Socrates, Plato, Aristarchus. Do you realize they were also philosophers? So somewhere there is a connection. But reading 2 pages of philosophy and 2 pages of science, we connect as is done nowadays. That is totally wrong. Okay, thank you.
Dr. James Dipankar Sen, please.
Good evening, sir. How are you, sir?
Fine.
I have a question not related to this directly, but I have some thought regarding this. What is your opinion on biblical cosmology?
Unfortunately, I am not a student of theology. Unfortunately, I have not read biblical cosmology or anything that's in Hindu cosmology. I have read a little bit. But mythology, I have not. So
Oh,
I am not the right person to comment on.
okay, okay. Actually, I was thinking something while I was
Okay,
reading the
I
Bible.
think, yeah, yeah.
I
You
could.
write it out, spread it across, send it for publication. See how people are accepting it. That will be a better way than asking.
Okay, 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 okay. Okay.
Mr. Pranay.
I would like to talk to you regarding this one day.
Okay, that's a different story.
Yeah, Mr. Pranay Kundu.
Hello. Yeah.
Pranay, we can't hear you.
I think this correction may be a little sketchy or something. Uh, we are either we move on or do you sort of wind up
No,
the
I
discussion.
no. I want to ask you a
Yeah.
question. With all these recent space discoveries, do you think they will inspire a kind of cosmic awakening or consciousness in everyday people, leading to a deeper reflection about life, purpose, and our role in the universe?
See, the knowledge about a subject, the knowledge about a notion, the knowledge about ideas leading to higher thoughts, they have to be taught. There should be teachers. A person on his own, he is much busy with his everyday life. How to earn, how to employ, how to remain sort of happy. To them, all this grand design is not affecting his everyday life. But it can happen. And only then people realize, oh, is it there? Oh, is it happening like this? Oh, they are like this. Before that, the society should take up this role of educating people. Our education system does not have these kind of things. Not even at the college level. Only where astrophysics or astronomy is taught, students learn that. But nowhere else. But this is nothing to do with the subject of astronomy. This is rather to do with our understanding of a symbiotic relationship with every living organism and the nature at the largest scale. That has to be injected. And that is why, for the last 22 years, it is a passion for me. Otherwise, I could have done a little bit of research and all that, which I was doing at Manchester earlier at Tata Institute of Fundamental Research. I realized that this story should be told, and nobody is doing it. They are doing it, but not in the scale that is needed. That's my answer.
Thank you, sir.
Thank you.
Dipawan, please ask your question.
Thank you so much, sir, for the amazing talk. My question was related to how close is physics today in trying to find out a grand theory of everything about the universe, especially with regards to the not successful, the not the complete success of string theory.
A very relevant question. But let me give you an analogy. If I give you a very nice camera, put you inside a room, and tell you that in one single shot, take the full picture of the room. Well, is it possible? No. You can take pictures of the four walls separately, the roof, the floor, but not the whole room. Taking the picture of the whole room, you have to come out of the room and take the picture of the room. Similarly, with our consciousness. Our individual consciousness till today is only a small subset of the cosmic consciousness. So part can never be able to describe the full, not in the complete. And say, so science will go on, science will make progress, our intellect will become more on a higher level, but we cannot say theory of everything. That is a mathematical design, not understanding. Thank you.
Thank you so much. That's really interesting. Thank you.
Ram sir, Ram sir, can I ask you if you kindly ask the question, please?
Sorry, what did you say, Dibendu?
I asked you to request you to ask the question to Dr. Duari.
You want to know whether I want to ask a question? Is that what you said?
Yeah.
No, there were some other hands raised. I thought you'll go through them. But now that you have told me, Dr. Duari, thank you very much for a very illuminating talk. And I am certainly at least marginally wiser than what I was 1 hour ago. Having said that, now scientists are proposing the parallel to the Big Bang theory, the Big Bounce theory also. Of course, like you said, science will go on. We'll keep developing our intellect. We'll come up with new theories so that we'll be able to understand things better and so on. But having said that, if Big Bounce were to, let's say, establish itself parallel to Big Bang or maybe superior to Big Bang or what, we won't know. But the individual processes that you discussed, say for example the birth of a star and the death of a star, etc., would still have been the same irrespective of what was the basis for the evolution of the universe.
If you take the existence of an individual star, the time scale of its birth, evolution, is generally very small compared with minuscule compared to the whole scale of universe expanding, becoming small, becoming going to a point. By the way, there are three possibilities. Universe is expanding, it can continue expanding, but the rate of expansion can slow down, and ultimately, in an asymptotic form, it will very slowly, marginally expand and remain like that. Second, universe is expanding, then it can stop, and again it can come together and become a point-like object again to produce another universe, big bounce, as you can say. Third, it is expanding, it can expand in an accelerated way. So nobody was sure. Everybody was finding observation which is supporting them. But in 1997, they found observation where it showed universe is accelerating. It is increasing. It's very fast. For that, in 2003, the Nobel Prize was given. 2006, the Nobel Prize was given. Right. So now we know that we are accelerating universe. What is the end of that? That means universe is accelerating faster and faster and faster. Soon, the stars, the galaxies, if they are still there, they will go so far apart. The universe will become totally cold, frozen cold, close to absolute zero. Right? The big death. So nobody knows because now just James Webb Space Telescope in the last 2 years have found observation which are doubting the accelerating universe also. So that is the fun of science. You know, it's
Yeah,
changing
absolutely.
very fast, very fast. But it's a
Thank
very
you.
good and relevant question. Thank you, sir.
Thank you so much. And I'm sorry, there were some other hands raised. Dibendu, please give them the
Yeah,
floor.
Mr. Orijit Havdar.
গুড ইভিনিং স্যার স্যার আমি বাংলায় প্রশ্নটা করছি
If you kindly do in English, it will be better. There are a lot of people who doesn't understand Bengali here.
Okay, sir. Actually, if there Big Bang happened, so is there a chance that the expand will be minimized with time and come to a point, and after that it will again create a Big Bang?
See, whatever
Thank
Mr.
you, sir.
Ramanathan was saying, I have the same question in a different format. So I've given the answer. There can be big bounds, but the present understanding that is that we are accelerating. We are becoming bigger and bigger every day. Right? I think we should have restricted to one more question and then finish it up.
Uh, yes, Pranay want to ask a question. Pranay, please.
Yes, sir. Sir, I want to know that you tell that it is expanding, but where it is expanding, the universe where it is present, what is the base of it?
Objects that I described, I showed you, forms only 4.5% of the actual universe, observable universe. 4.5%. The other 95.5% is something called dark matter and dark energy. Dark matter, there are a lot of theories. What is dark matter? Till today, nobody has found. Dark energy, there are much more exotic theories behind that, but nobody has found. But it said, for something, for example, it has a negative pressure. What is a negative pressure? In mathematical terms, you can write negative pressure. P as minus P. What is the physical meaning? That dark energy can be fueling because it is negative pressure. Pressure is when it is coming together, it can fuel the expansion. Till today, at least, I do not know what is the clear-cut understanding behind the reason of expansion. Apart from the earlier concept, the Big Bang produced that inertia of the explosion of later happened, but it is continuing, becoming more and more because maybe of the possibility of the dark energy. That much I can say in my small knowledge.
Okay, thank you, sir. And sir, I have one more question that uh, Earth rotates in its own orbit, but why it's rotate?
Because everything in this universe is spinning. At the earlier stage of the formation of the solar system, there are small, big rocks, objects hitting each other, colliding with each other. And this collision has given birth to the spin. In addition to the inherent spin of the solar nebula, which itself is a spinning disk of gas and dust.
Okay, thank you, sir, so much.
Ashmita want to ask a question, and this is the
Last question, last question,
Yeah.
because I have something, I have a webinar later on to have to take a class in US.
Okay.
Yeah. Ashmita,
Hello, sir. It's been a
hello.
great opportunity to be in your meeting here.
Thank you.
Just wanted to ask one question. You were just saying about dark matter. This question just struck me right now that if we have never found what dark matter is, never seen it, never felt it, then how did we even come to know that it exists?
1915-16, Einstein said if two objects, very heavy objects, are going around each other, they will create a ripple in the space-time as if waves. Nobody believed, but theoretically showed, mathematically proved. That was discovered in 2016, gravitational wave. So, this is the brilliance of science, brilliance of human intellect. Even if it is not there, you propose a situation, you propose a method, you propose new objects which can later be found, discovered. That's how science has progressed. Thank you.
I just request AR sir to make a closing remark. AR sir, please give a closing remarks to sir so that we can.
You want me to give the closing remarks?
Yes, sir. Yes, sir.
So, first and foremost, thank you very much, Dr. Duari. And I'm absolutely certain that this is not the only lecture that we want from you. And we'll probably require a series of talks from you to really understand this complex, will make us understand ourselves better, really speaking. I mean, it's not easy, and but if this understanding comes, I think we will all be better human beings, quite frankly. So this is my summation. But outside of this, as closing remarks, if Dibendu has noted down, please check with Dr. Duari's calendar and get us to hear him a little more frequently or over the next 2 years based on his convenience. Some more insights into this wonderful subject, which I think all of us need to know, because the standard academic systems don't really give us much knowledge about this.
Thank you, sir.
So thank you,
Dr.
sir.
Duari.
Thank you very much.
Thank you.